All right. So welcome everybody. We're gonna be talking about TDD, how to learn TDD. I want to just share my experience learning TDD. This is my first software developer job, so I was just learning how to write code and write tests and all that. Um, but yeah, it didn't really make sense to me at first. How can I write a test and the code doesn't even exist? Like that really stumped me up at first. And I started really understand that it helps you understand the inputs and the outputs and eventually got more confident in it. And then I started to lead lunch and learns and in different communities inside my company, I started to share what I've learned and to teach people. And through teaching people, it made me realize that I have a lot more to learn. And um, and I've basically just been going through that journey ever since, just teaching people and learning more. And I mean, really, all of us, for software developers, like we're gonna be learning the rest of our careers and the rest of our lives, really. Yeah. Some announcements before we get started. Next month, I'll be giving a talk on long methods and how to, reduce those and work, kind of like some things with working with legacy code as well. And then in April, we have Arlo Belshi. He's going to be talking about how to, avoid rewrites, and he's a great leader in legacy code, has a lot of knowledge there. All right, a lot of people have already signed up for that, so definitely come out for that. And then in May we have another speaker, and that should be announced shortly. But yeah, without further ado, Garrick, take it away.
All right. See if I get my screen sharing properly configured here. I'm going to go for the other desktop and give it a shot to share and then start. Okay. Hopefully you've got a full screen visible of that with Tactical TDD Introduction Q1
Yeah.
2024. All right. Excellent. So it's kind of interesting. This is not the first time I've given this talk, but I took a little bit of feedback, some input, and did some more thinking about it. From I think I gave this in August of last year, somewhere around there. I don't remember off the top of my head, but I think that's right, sometime in August 2023. And it all kind of came about when I'd had someone ask me, it's like, okay, so how would I go about learning TDD today? Given the situation that I did it over 20 years ago, and the questions kind of came up. It's like, so well, what's different? And as a thought, as a response, it's like, well, in a way, everything's different, and in another way, it's like, well, really, there's nothing really that different. So a little bit of maybe the classic consultant's answer of it depends. Um, but so my goals for this talk overall, I want to dispel a few myths and maybe try and take a shot at giving a good definition of TDD. There's a lot of bad information about what TDD is largely due to the name. And I think in a lot of cases, people hear it and they get hung up on there's, some like 5 popular myths. One is that TDD is just a synonym for unit tests. It's like, oh, TDD, yeah, that's just unit tests. It's not. TDD says, well, you have to write all the tests first, and that can't possibly work. And it's like, no, that's actually not it at all. In fact, you shouldn't be doing that. Um, some people like to make the accusation, those who possibly see the world from the architect's ivory tower, where they don't code, but they have people who do that for them. that, well, TDD excludes high level design and architecture, and it's not the type of thing that, is really workable, which is completely wrong as well. Um, and sometimes people, I think in some cases, get really overzealous with TDD and think that, that TDD covers QA, and, with enough TDD, you can really even replace QA aspects, which I think you can for some smaller scope on projects, maybe, but with a complicated enough system, no, you're not going to get away with it. Not with anything that's particularly big, not with anything that's particularly commercial in value. You don't get to just say, we're going to get rid of any sort of notion of QA work, because we do TDD. Um, so I want to talk about kind of what knowledge and tools have changed in terms of supporting TDD, which is all, pretty much positive from where things had started in the early 2000s. For example, back in 2002, when it came out, the book Test Driven Development by Example by Kent Beck was by and far like the best, if not really the only solid resources, unless maybe you had followed him along on some email list or some news group or something like that. Um, but even then, some weird things started to pop up. I remember having just a horrible laugh at the expense of a large software company in Redmond, Washington, who produced a blog post saying that they had a TDD tool that, given a class interface, would generate your tests. And people really beat up on that one, for example. So again, lots of back and forth and changes in terms of knowledge and tool support. And overall, kind of the concept that I want here is to kind of talk about a kind of a tactical guide to learning TDD, as well as how you can communicate it out. um, Different people's paths are different. You may be further along, you may be brand new to all of this. My hope is that as I go through, if nothing else, I might give you a few points to consider, ideas to backtrack on, possibly some cool resources to go take a look at. And maybe if you're lucky, the occasional Zen slap of, oh, I never thought of that. Because let's face it, sometimes that's really the fun of learning. Okay, so let's get down to and talk about a definition of TDD. And I'm going to go with a quote from the man himself. TDD is a design approach. Okay, that's it. Thank you for attending my TED Talk. No, I'm kidding. Um, as the joke goes. But I have accomplished a primary task, which is pointing out, from the lips of its own creator, or who's most famous for it, that TDD is a design approach. Now, at that point, I would like to turn back indirectly to Mr. Kent Beck and say, Kent Beck, great at programming, terrible at marketing. Because the real way to look at it is that TDD, of course, especially for those of us here that have done it, it is not about testing, it is about design. One of my favorite, in an alternate universe, I either would have been a stand-up comic or a really better paid, successful marketer, rolling in money. I thought, no, the T's in the wrong place. If you think about it as DDT, as in design driven by tests, you can think back to the old terrible chemical that, fun fact, was banned in 1972 by the EPA due to environmental effects on wildlife and potential human health risks, because that's always fun. But it was a good way to kill mosquitoes from malaria. But DDT, the idea of killing bugs, kind of the marketing angle of, TDD kills bugs in your code, keeps them dead. So yeah, and to me, that's really the way I look at it. Is it's design. It's design that makes your it's design that makes your code maintainable using test mechanisms. And as I mentioned earlier, you will not write all your tests first. You're going to be writing things, of course, in small increments. And some people say that, TDD can make your code hard to understand. And there are some traps with TDD that you can fall into if you're not careful. But overall, if you focus on the correct approach, which we'll be talking about in just a moment, it helps make your code understandable and more maintainable. Um, My personal best argument for TDD is that your tests demonstrate that every line of code delivers value. If you think about things in terms of clients of your code, your tests, when you do TDD, are the first true use of your code. It's actual executable proof that your idea has business value and it can deliver. And it's holding your code accountable before you've even shipped something to production. So, how? Well, this is kind of the core, as the joke goes, easy to learn a lifetime of master slide for the perspective on TDD, or design driven by tests, if you want to put that spin on it. All you really need to do is follow the life cycle. Red, green, refactor. Red, as the diagram goes, you write a failing test. Your test framework shows red. Green, you make the test pass. Blue, you refactor. And the whole part of this is not just that you're doing that, but the nuances that I think in some cases people get tripped up on is that you're following Uncle Bob's three laws. If you're familiar with Uncle Bob Martin, author of a number of books on TDD and clean code, one of which will come up later, he came up with three laws when he was practicing TDD early on that Kent Beck, I believe, liked and thought were a good approach. And the three laws are, number one, you write production code only to pass a failing unit test. That's that first step in the red. Number three, you write no more of a unit test than is sufficient to fail. Compilation failures are okay failures. And number three, when no more production code, write no more production code than necessary to pass the one failing unit test. So you're doing these in all these small steps. While you're doing that, as you're doing it in a cycle, you want to keep an eye on what's called the four rules of simple design. And that are that your code passes the test, reveals intention, has no duplication, and has the fewest elements. Those last 2 points are where the blue and the refactoring really comes in, with no duplication and fewest elements. And combining those, I believe, with practice, with thought, with some experience, they are and can be all you need fundamentally to do good TDD. Now, notice I say fundamentally, because that's not all that gets involved. And as we'll be talking about soon, there are certain elements that you need to pull in to help you be effective in your testing in order to bridge the world and merge the world of communication of getting something accomplished between tests and code. And surprisingly enough, if you step back and you say, well, if I'm going to drive my design by tests, that implies that I have to know something about writing a test before I think about design. And while it feels like a chicken and egg problem, in a lot of cases, and with a lot of demand and expectations in the current software development world, if you're doing your tests after you've written your functionality, you will have probably been forced to nudge yourself towards a situation where you're at least getting the skills, if not getting into positions where good test last development is fairly is functionally the same or functionally equivalent of test-driven development, and that a good test last development will cover all your test cases. You will cover your code. Could you have done it easier with TDD? Quite possibly. Could it be easier to read, more succinct, more maintainable? Most likely, because those are some of the aspects that TDD will drive. But if you're getting familiar with tools and learning how to write good tests, you'll start to get the feel of kind of the back and forth. There's a little bit of a joke that code that's hard to test is trying to tell you something that's going to be hard to maintain. So, well, this code is hard to test. It's like, well, that's telling you something. If it's hard to test, maybe if you made it easier to test, it would be easier to work with, easier to maintain. So when you start to get into this, there's a little bit of an interesting comparison that goes on in terms of building up some of your testing skills and your testing familiarity. Getting familiar and comfortable with the idea of I'm a developer, but I'm still responsible for testing my code. And for that, I like to point to the world of skateboarding, believe it or not. Um, and the fundamental understanding, which I suffered as a tween, 12, 13 years old, and learning that you can't kickflip if you can't do an ollie. An ollie is the fundamental skateboard trick for a huge number of skateboard tricks that you want to go off and look cool doing. Let's see if I can get this going here. I've actually got not just the text, but the video. It is a core component. So we can see here in a moment. In slow motion, move the board up, move your feet, position, stabilize, and land. Now, of course, this individual makes it look simple. Uh, Full transparency, I never learned how to ollie. I broke my left wrist while skateboarding. My father threatened to take it away if I broke any more bones. And of course, the irony is since then, he's broken a number of bones getting thrown off of horses. And my mom likes to encourage me to remind him of his standards, that perhaps with a couple more broken bones, certain horses will be taken away. But I digress. So TDD is like a bit like this. You need to understand some of the notions of how unit tests work, what makes things testable, and getting a sense of code design and refactoring before you start to drive your code with tests. Learning tests first, learning test last, as it were, is something that really honestly helps you learn to test first. So if you think an ollie is hard, try writing maintainable software. This is kind of a fascinating diagram that I really liked, and it didn't sink in too much until I saw this, and this was probably just a couple of years ago. The folks at Tech Excellence IO um, there's a credit down in the corner here. If you take a look for the TDD transformation iceberg, you can track it down, and there's a really good article that talks about this. This effectively the concept that in order to do TDD, you still have to be able to do this level below. Effective coding is right below effective TDD. And below that, you've got effective tests. And below that, you've got a testable architecture. And then at some point, you still have to have working software. And ideally, as problematic or as difficult and challenging as it may be, since people are messy, you have to have a certain level of psychological safety in order to build up and get a testable architecture that your team agrees with and you're willing to commit to working with and building on top of and understanding what are making tests effective. We'll get into that in a moment and what constitutes effective code. But the notion that if you're going to transition to doing TDD and you don't have good coding standards, you don't have much tests as it is in your current code, and you know that's a concern, and you're not sure about how to tackle some things. In a number of cases, what you'll see out in the wild is approaches to TDD will fail because existing code will resist testing because your team and your tooling aren't ready to dive in and take advantage of what TDD can do by doing test last, by just going in and say, no, that's okay. We're going to try some good clean code design and we're going to get tests around it and move from there. And there's nothing wrong with doing that. But the important thing is that you have to be aware of it. And sometimes you have to ask yourself in terms of the organization, do you need all of those? Does it need to be 100%? What if you had a small product that you could enhance the tests for and then start adding new functionality to it in a TDD fashion? Those are always possibilities. And so the question becomes then at this point, it's like, all right, so what's effective code? What does that mean? I'm going to go off and give you my favorite acronym that I have the ego to believe trumps them all. and excuses me from writing an entire book. To me, effective code is ETC, easy to change. And as that is a wonderful consultant style hand waving of saying all the elements about that code make it something that is easy to maintain for developers, easy to change. If new requirements come in, you can add new requirements. It's extensible. Now, there's assumptions, of course, in there. Things about the code being clean, that it's refactorable, that you've got good test coverage. All that sort of stuff piles in. But at the end of the day, if you're not looking at a code base and your team doesn't say, yeah, that code's easy to change, then you're not quite there. You don't really have effective code. There may be sections, there even may be layers or certain aspects where you say, oh yeah, that area of the code is easy to change. But there may be stuff over here. There may be some dark depths. There may be a service that's being worked with or something like that that resists that. But to me, that's kind of the fundamental for effective code is code that's easy to change. So then what about tests? What makes effective tests? Um, I have a favorite for this. I can't take credit for either of these. The one with the pyramid, as it's called, is actually to me is the classic testing pyramid. And this was stolen off of Martin Fowler's blog. If you do a Google search for Martin Fowler, sorry, not Flower, Fowler, Martin Fowler test pyramid, you'll find his little example here. And there's two things that I like about this. It shows roughly kind of a distribution, the idea that you want a bunch of unit tests, you want some service tests, you're going to need, and you'll still have some UI tests. But then you've got the warnings on the left and right hand side. The left side with the turtle and the hare, those are for developers that tell you, man, unit tests to me, I've got a simple definition: RAM and CPU. If it touches anything other than RAM and CPU, to me, it's not a unit test. That also means you can do fun tricks, like depending on your tooling, like JUnit, you can throw multi-threading at it. You can kick back and say, how many cores do I have? Awesome. Let's go and crank it up. Same thing sometimes with like number of workers in terms of running with Node and configuring NPM test runs to run off and segment sections of your tests and block them off and run them concurrently. Um, Now, of course, the thing that I like to scare business folks with is the other side and explaining to them that unit tests cost cents and UI tests, the flashy, pretty ones that, a lot of times they use to hypnotize upper level executives in demonstrations at the end of a quarter, those are expensive. They're expensive to maintain. They take a long time to run. They're fragile in and of their nature. Um, and the less you have to rely on those, the better. So to me, that's effective tests. That's a good shape. Now, the reverse of that, appropriately enough, is called the ice cream cone, where you take all of the goodness of the shape of the pyramid, but you flip it upside down. And at the bottom, you've got small, if any, trivial amount in the ice cream cone for unit tests. You've got maybe some more integration. You're relying on a lot of automated. And then the ice cream scoop of sadness is at the top. And I call that sadness because that means that you're not using and automating and using computers at their best. You're abusing humans, that there are poor humans. Someone somewhere had to open up a Microsoft Word document and follow steps and write things down. And that is a sad thing to do in 2024. Or I would argue even in the past 2 to 3 decades in terms of test automation and capability. So again, you want the pyramid, not the ice cream cone. And the interesting thing about this is that both code and tests, as you go through, will be significantly impacted by architecture decisions. I like to tell people as a cautionary tale and a warning that if you want a testable architecture, really scrutinize your third-party solutions. There are tools out there, both open source and commercial, Some of them are really cool, some will really do some really neat stuff, but depending on how they were built, they will either be very flexible and open to supporting automation and unit testing levels or integration testing levels, or they will be hostile in language feature choices. Making certain objects like, final and they can't be constructed with new because some architect in an ivory tower decided that that wasn't the right thing. And now all of a sudden, you're left trying to unit test the foo object, but you can't create an instance of it in order to test it and work with it. Horrible things can happen like that. Um, I'd like to think that over time things improve, and I think in a lot of cases they have, but you still have to be aware. In some cases for commercial products, you might have to ask about developer and test server license costs. Sometimes commercial companies will do that. And as I indicate here, hint, if they're not free, run. I don't know about you, but as a developer, if someone is going to charge for some really cool server that runs great in production and saves us all this trouble and all this money, I better be able to fire it up on my laptop, the test machine, anywhere else, the ad hoc server under my desk when I decide I want to do some load work, without having to bug someone or beg someone for a license in order to do such. So there you go. Um, so when you get into all that, another aspect here is talking about maintainable code. Once you've got this, things that you want to do, things you want to be aware of. I have some nice long-standing book recommendations on maintainability. Specifically, these are a kind of favorite four. I mentioned Uncle Bob earlier. Once you're doing writing clean code, you're writing clean tests. You've got an architecture that's capable of sustaining that iceberg, and getting you to being able to do TDD or doing test last even successfully. Books that'll help you do that if you're not already familiar. Clean Code, Uncle Bob's book. Here's a favorite that is a little hard to find, unfortunately. XUnit Test Patterns is kind of a Bible, and in my opinion, it's completely overlooked. It's 949 pages of detailed XUnit concepts and testing approaches. The funny thing about it to me is that I bought it like a decade plus after doing TDD, and when I flipped through it, I still learned a few new things and had picked up and ended up reflecting on and looking at some concepts that I had not considered or even tried. Even though it's out of print, you can find and legally acquire a PDF version from Inform IT, Inform IT, one word, slash person publishing company. And if you really want to know everything about unit testing and the XUnit framework, this is a great book. Kind of a personal diamond in the rough that I discovered a few years ago. Refactoring, kind of a chicken and egg. You can't really do safe refactoring without the tests. And if your tests are hard to write, they're going to be hard to refactor. So being aware of the structure of code and some of the things that you will learn in the refactoring book, if you already haven't started diving in and taking a look at that, that's going to help put ideas in your mind. And then a step past that, plug for my former employer, the Josh, the owner of Industrial Logic, Refactoring to Patterns. Great book about the approach of saying, not only am I going to refactor this code, I'm going to move this into good-looking design patterns, particularly in terms of being powerful in the OO world. And so there you go. There's some general concepts, some direction about how to be able to support doing TDD, or getting good testing, test last or testing at all, going inside your organization for yourself. So let's talk a little about this roadmap I've been hinting at. Um, there's a saying that the map is not the territory. And of course, my one-off stand-up joke is that, yeah, but having one beats the hell out of getting completely lost. So I'm going ahead and I'm proposing this kind of map guide in terms of learning and working with and possibly introducing TDD into your organizations, your current, maybe your next organization, and trying to put myself in other people's shoes in terms of how to look at it today. because my experience and my shoes were different at the time I did this. In fact, it was 2004, and I had a habit of journaling at the time, something I've fallen out of since. But I remember years later going back and looking at in the first weeks of one of my first full-time XP job and making a note. And this is actually a quote from myself. Apparently, I'm big on quoting myself and looking back at the presentation. I don't know if that's a good thing or a bad thing, but I'm going to roll with it. Um, this job is either going to make me or break me. Um, Good news and spoiler alert. I think it made me, definitely made me a better developer. But I will tell you firsthand, I was right about it being a challenge. Um, the old joke about drinking from the fire hose. A bit of humor, of course. If you've never seen the movie UHF by the wonderful parody talent Weird Al Yankovic, go and dig it up. It's from the 80s. Some of the stuff may not have aged very well, but a lot of it is just hilarious because it's still Weird Al. And going in and starting on an XP team that basically followed the entire basics of the 1999, the original White Book, Extreme Programming Explained, Embrace Change by Kent Beck. Those were all the steps we did. We had an on-site customer. All production code was TDD'd. Everything was pair programming. We were doing what is now referred to as trunk-based development in order to support continuous integration. There was a small little box that sat in the corner running some very new software called Cruise Control, which was the first continuous integration server software to ever exist. And it was convenient enough because we were doing Java and it ran on the Java platform. And like I said, this was a terrible way to learn. It was also fantastic. Um, I was committing code on day one, and my lack of confidence got backed up by the fact that I had a pair with me at all times, and there was a bunch of test coverage already in this code base as we went through. And if we made a mistake and the build broke on our laptop on our pairing stations, we figured it out. We fixed it. If we were stumped, we asked for help. It was a big open room, and we moved on. After 20 years, I got very comfortable with that notion of iterating. And the videos and stuff that I'm going to talk about, they're great, but ultimately, as you'll hear people talk in terms of learning, it's no substitute for doing it yourself. So in order to do it yourself, as the saying goes, attributed to Picasso originally, good artists copy, great artists steal. And I kind of wanted to be a great artist for coming up with this tactical TDD approach. And so I blatantly stole the structure for recommending this off of the surgeon skill mantra of see one, do one, teach one. And those are for little things like, how to do certain sutures or doing certain cuts or certain approaches or applying a clamp or whatever they are. In this case, I'm talking specifically about different levels of working with and learning various aspects of TDD and the tooling and philosophies and all the things that around it that support it and make it scale up and make it support building any software you want to build. So I broke it down into 5 acts. No, I'm not Shakespeare. The fact that there's 5 acts or 5 categories is the only way that this really gets the Shakespeare picture there. But hey, Shakespeare, that's cool. But I broke down each act, the notion of seeing and doing basic TDD. I'm going to talk about a suggested video. I'm going to talk about specifically when you do this, what to watch for and how to recognize good content. Same thing with advanced. See it, do it. I have a suggested video. And also, once again, what to watch for, recognizing good content. I'm also going to have tips, lots of tips. And then talking about showing all the TDD. The notion is we talked a little about earlier about when you go off and show this, you learn more as you're teaching it. Realize what you need to unlearn or realize what you still don't know. And it's a little scary, but it's one of the good steps in terms of getting your understanding of TDD, as well as helping others. I'm going to talk about advocating for TDD. different approaches, getting different exposure to it, things to look out for, some of the cultural issues that you run into in organizations. And in terms of piloting, talking about some possible good real world types of projects to dig into. Or I'm going to talk about the idea that you can just fake it, because sometimes that's the right thing to do. So, Act 1, basic TDD, see it. If you recognize this gentleman, you're in good stead. This guy with the glasses here is a bloke from the UK who hosts the Continuous Delivery channel on YouTube. He's a great software crafter. He makes great content. His name is Dave Farley, and he has a TDD tutorial for beginners. And I went through, and I watched it, and I like what I saw. And the bullet points here are specifics about what I saw. I saw him, of course, talk about and do red-green refactor. Great. He specifically talked about Uncle Bob's 3 laws, as I mentioned earlier. Not allowed to write production code unless it's making a failing test. Not allowed to write any more of a unit test sufficient to fail and compilation is failure. And you're not allowed to write any more production code than is sufficient to make one failing unit test pass. You'll see him frequently running the tests. This is another favorite. Because part of the fundamental nature of TDD as I think about it is a learning process. You're constantly learning with the code. Always call your shots. When I see people doing TDD demos and they're not saying, okay, I'm about to run this and I expect blank to happen, I get a little on edge because either they're too scripted or they're not appreciating TDD maybe the way I am. Maybe you can call me a TDD snob for that. I'm okay. I've been called worse. And then, of course, going back again, the 4 rules of simple design. That it passes the test, reveals intention, no duplication, and fewest elements. Do they do arrange, act, assert? This is another thing that happens when you set up a test. You arrange your interactions, you do an action to execute some of your code, and then you assert what you're expected that code execution to have done. So this is just one video. It's one that I liked. I loved his approach. I loved everything covered. There may be others out there. I would suggest that you seek out something possibly in your favorite language and toolset. However, take notes of those bullet points. Look for presenters who are covering those things as well, because to me that says they're definitely on the design train, that they're looking at this as design driven by tests, that they've got a good depth of understanding of building solid, maintainable code, maintainable tests, good architecture, everything coming through in a fractal approach. So now you've seen it. Okay, do it. Oh, wait.
I sometimes get asked how to begin with test driven.
I didn't want to do that. What I actually wanted to do was go to the next slide. Try that again. So do it. Focus on TDD basics. If you've never done this before, you don't necessarily have to spend, an hour or 90 minutes of frustration trying to set up an IDE or something. There's a fantastic site called cyberdojo.org. You can start doing FizzBuzz in the language of your choice. You don't need to download or install anything. Just fire up a browser. They might ask you for an email to set up a free account. It's been a while since I played with it. But pick a language you know and you're comfortable with, and give FizzBuzz a try, which is the classic. If you're not familiar with FizzBuzz, it's based off a British drinking game where you're supposed to count from 1 to 100, and for multiples of 3 you say fizz, for multiples of 5 you say buzz, and for multiples of 3 and 5 you say FizzBuzz, and that's it. It sounds simple, but it's actually kind of an interesting little problem. Kind of along the lines of ridiculous business rules that you might run into in the real world, which is kind of why it makes it a fun little programming exercise. As you go through, get familiar with some of the testing stuff, like before each, before all, after all assertions. You can start playing with some of those, just even like within CyberDojo. And as you do it, think about how TDD infacts the code, and then maybe try some other katas in your strongest language. FizzBuzz is a very simple and adaptable, but for fun, you could go through, try it in every language you know, even stuff you haven't touched in a while. That might give you exposure to things like, well, what are the supported toolings in this language? What does the community support? Is there unit testing out of the box in the standard library? Ruby. Do I have to download or randomly pick something because I'm suffering with JavaScript? Whatever those things might be. So that's Act 1. That's the basics. And once you're familiar with that, you're thinking, okay, I get it. I get TDD. Well, that's where things get a little bit harder, of course. If you're tired of FizzBuzz, look into advanced stuff. My personal one in this case is Grief Ferreras. I may mispronounce his name. He has a great video called, quote, "This stops 90% of C# developers learning TDD." If you know roughly remotely OO concepts with any language, OO and Ruby, Java, Python, whatever, or C#, you won't necessarily be put off by the fact it's C# if you don't know it. But going through and watching what he does beyond the basics is the important part. And it's why I chose this as the recommendation. He makes use of test doubles, which I'll be talking about a little later. And that's one thing to look for if you're looking for other comparable videos. Are they using test doubles? Do they fake it to make it with external services? Writing interfaces. People will talk about preferring mocks versus fakes. And in some cases, you'll run into weird scenarios where some of the unit test stuff will end up moving out of RAM and CPU and end up touching actual databases. Some personal notes here. Test containers are not the same as classic unit tests, as I mentioned, with RAM and CPU. And I've spent a lot of time with mocking libraries. If given the choice, I'll take a fake any day. It's less cognitive overhead. And if I'm having to write an interface anyways for good design, then that's just another candidate for my interface. So those are my own biases. I'm happy to discuss over a beer at some point or argue with. But what gets interesting is that some tools and frameworks will also take opinions. For example, Ruby on Rails says your database is fast enough locally. Don't muck around with fakes. Don't muck around with a in-memory special database that might behave differently. Just use your damn database. And so that's what you do. And in some cases, you make the decision of, I've decided to go with Rails, so I'm going to accept and go with some of those testing framework trade-offs. So now you've seen it. Then the interesting question becomes, how do you do it? How would I recommend you do it? Well,
if you are like me
that's
and you are
twice now.
thrilled to learn.
Keep hitting on the wrong thing instead of continuing. I'm launching the video. Oops. Oh, it's my interjection. Oops.
If you are like me and you have failed to learn.
Let me try this again and check my slide navigator here. So I was going to go in and show it, but before I do that, I'm actually going to interrupt myself and have people say, hey, so wait a minute. I mentioned test-driven development by example. And this is a little bit of my 2004 rework of this presentation. I didn't pay too much to it, and I went back and took a look, and I realized that even though it's a bit dated, the concepts are solid, but the book is broken into 3 parts. And part 1 is a step-through example of Kent Beck showing you how to do TDD, code examples all the way through. That's fine. I honestly feel YouTube can replace part 1. Part 2 is talking about some of the tooling, the XUnit framework. Again, you can pick that up. YouTube really kind of replaces part 2. But part 3 really kind of justifies paying the money to actually buy test-driven development in 2024. And that is, part 3 has an entire section called Patterns for Test-Driven Development. And he mentions some really useful and some really cool stuff that starts to get into the things that are covered in the second video. He talks about mocks. He talks about a variety of approaches and ways to help make your code testable and drive it with tests. It's small, it's compact, and to me, it's a really good resource. And it was one of the things that was kind of missing from the first time I did this presentation. So that interruption of myself aside, taking a look at the next step. If you're going to go ahead and do it, you've got a notion after those videos of mocks and fakes. test doubles as they're called. You're bored to death with FizzBuzz. You want to do something a little more realistic. My approach to this is start on your own and evolve it. Jokingly here, I've got yet another effing to-do list. No, the world doesn't need another to-do list. However, if you want to learn TDD, apply it in a small project, a to-do list is perfect. Why not? Pick a language you know and you're comfortable with. Come up with a version that holds the to-dos in memory. Version 2, use a flat file or browser storage. Version 3, talk to a SQL or no SQL. Version 4, weld in advertising and, have Jeff Bezos scrape the page and, give you sale prices for things on your to-do list if it comes up with stuff that Amazon sells, because that's helpful. Whatever it is, take it, start with the basics, evolve it along, and when you want to know something, dive into it. Take a look at integration stuff and things that help in terms of flexible architecture, like doing database migrations, for example, with Rails. If you haven't done before, if you haven't used a database migration tool, maybe this would be an example for why you might want to play with and set one up as part of a core of your project. A couple of traps to watch for. Not mocking what you don't own. Don't test the system itself. Isolate things that are uncontrollable. What's uncontrollable? Well, random number generators, the system clock. There's a long-standing pattern called the mock clock. For the love of dog, don't just reach out to system time and do something. Put a barrier in there. Make it inaccessible for a good reason, and that reason is testability. And as you're going through and building that up and getting familiar with things, you say, okay, well, how do I decide? What do I want to do in terms of starting? And I've come up with my spin, which in this case, in terms of good artist stealing, I put a nice spin on two acronyms I came across, and I really like this as a way to combine two acronyms into something memorable, which is part of my list of tips here as I go on. There's about 5 tips. Put your test at the corner of first and zombies. First and zombies, kind of like an intersection. I can't take credit for first and I can't take credit for zombies, but you can give me credit for putting your tests at the corner of first and zombies. What the heck do I mean by that? Well, let me give you both of those acronyms. First is about how your tests contribute to your code base. And this is originally focused on unit tests, but in my opinion, they should be applied to all tests. They're fast. Tests should be fast. They're independent. Not going to mess with each other in terms of setup or dependency, or leaving cruft somewhere like a database. Integration tests, I'm looking at you. They're repeatable, idempotent, if you will. There's a nice scientific word. The notion that you run them over and over and they behave the same. Self-validating. Every test should have some sort of an assert, or if it doesn't have an assert, you've got maybe a little bit of a comment in there as an apology that says, this will throw an exception if blah, blah, blah is wrong. And you expect the exception, or you have a tag for it or an annotation or something, or you don't expect to throw an exception. And they're timely. They're relevant to the work that you're working on at the moment. And so that's first in terms of how your tests should contribute. And then in terms of what should you cover, what aspects of your test, because I mean, you could test code until the cows come home, but what should you focus on when you're saying, have I done enough TDD in terms of driving out function? James Grenning has a great article called TDD Driven by Zombies. And that was where I blatantly took the zombies acronym from. And it should note that aspects of your code that should be covered are zero case. I've got a controller, should go off and fetch something. What if it doesn't fetch anything? Should it return an empty collection, or should it return null? The one case. Okay, what does it look like if I've only got one thing? The many, ZOM. How about we then talk about boundary conditions? You've got minimums, maximums, just before, just after, just on. Those are ones that the diehard testing nerds love to poke at. And then, of course, interfaces, specifically talking about what you've exposed contractually, or implicitly. If someone passes in a value that doesn't exist, do you return a nice error message? What's the contract with it? Does it throw exception at runtime? Whatever those types of interfaces, either explicit or implicit, are you testing them? And then all of those are kind of wrapped in an axis of the notion of you want to make sure you're exercising any exceptional behavior, especially things that might not be obvious either in reading the code or understanding what the business value is. Tests are a great way to call that out. And then you want to look at your simple scenarios and solutions. You, of course, want to get the happy path, but also getting those exceptional bits and kind of getting the most straightforward way of going through and testing. Tip number 2, level up your design skills. These are a few favorites. If you're doing OO stuff and you're not familiar with the book series Elegant Objects, strong recommendation for Elegant Objects. Great book series. Personally, I like the first volume more so than the second, but there are a lot of things that kind of push OO from what a lot of people think about bad OO concepts of, oh, I'm going to have this class hierarchy and, that'll solve all my problems, which, by the way, is a horrible thing. But Elegant Objects pushes things more towards functional approaches in terms of testability, statelessness, returning new objects, getting good encapsulation. There's 3 primary accesses in OO, which is polymorphism, PIE, polymorphism, inheritance, and encapsulation. And when you take a look at percentages, split out 100% on your pie, you want as little I as possible. You want as little inheritance as possible. Getting encapsulation should usually be a strong number, and polymorphism is good too. People can have different discussions. That's another great beer topic in terms of OO. How do you like your pie? Polymorphism, inheritance, and encapsulation. But also in terms of testability, seek out what your community's TDD supporters do. Look for TDD on insert your language here, or TDD on your favorite web framework there, and find out what people are doing. Go on YouTube, see if there's examples of people doing TDD with that thing. That will help give you a leg up as well. Researching test doubles, getting familiar with them if you're not using them already, understanding the differences between mocks, that they have their own tooling. They're a bit more to learn. It's a little my own bias. Stubs. Sometimes languages will support stubbing things real easy. Java is fantastic for that. You can create anonymous instances of classes. You can stub things out real easily without necessarily relying on a lot of, mocking or framework sort of stuff. And fakes, again, this is my personal favorite. If you're already going to have a good an interface implemented, using a fake will just make it easier to write it in your own domain concepts. And so that gets into an interesting one. I'm talking about all this stuff. I've talked some advanced concepts. Folks may or may not be too familiar, but there's a little bit from time to time of some arguments that come up in the TDD community about, do you design from the inside out or you design from the outside in? And that is where I suggest that you actually try both schools of TDD. There's 2 factions. I don't think they're quite as bad as East Coast versus West Coast rap. I don't think shots have been fired over them, at least not anytime soon. In the 2000s, there may have been punches thrown in pubs, but that's the London folks for you. I'm just going to leave that as it is. The Detroit or classicist school really kind of follows along a lot of what Kent Beck was showing and teaching in test-driven development by example. But there is an entire book in the London school. It's called, it's referred to as the Goose Book, GOOS, which is Growing Object-Oriented Software Guided by Tests. And that book really focuses on the London school, and it talks a lot about mocking and setting up dependencies. And as a shorthand, think about the Detroit school as inside out. I talk about a small piece of code and I kind of fake it till I make it and get the code growing out of the system. And the London school is outside in, and it says, I've got a UI and maybe I do this and I do that. Oh, does it talk to a user database? Yeah, but it's a fake user database. Don't worry about that. And then you go in and you drill into the user database, and then you do this and you do that and you do that. The interesting thing is that Detroit kind of digs into to discover requirements is kind of its big advantage. And the London school kind of tends to abstract things more away at a higher scope level. Last but not least, I know I've thrown a lot of tips in here as we try and get through our sections of our acts, but in terms of other learning, this was a lot of fun. They come up every year, hosted around about November. Coderetreat.org. The entire point of Code Retreat is actually a great one-day opportunity to show up with other developers, to pair program in section rounds, possibly in languages you've never tried before, 40 minutes each. And by the time you're done and you've worked on this part of this problem, and by the way, there's a hint, that's from Conway's Game of Life, that little logo there, the pixels. It's a 0-player game that emulates a life system with certain rules. And the goal is to try and complete some of the rules and write the rules for the whole game. You won't get through it. You don't have time. And you think about what you did. You think about what you applied in terms of doing TDD. You think about how your pairing went. And after the time that you're done, you erase everything you had. In a lot of cases, you might rotate and start working with a new pair. And if you've never done it before, it sounds completely weird, but you practice TDD with red, green refactor. You follow the 4 rules of simple design, and it is structured to be outside of work code to help you just focus and play with the concepts around TDD and around good code craft. This is a lot of fun. I have had folks, as a side note, use this as an internal tool to introduce TDD and pairing into organizations in a nice, safe way. Because, again, you're not working on production code. You're just learning the concepts. You're just applying them. You're just getting a feel for them in a safe environment. So that's all of Act 2 of my tips. I mentioned Act 3. You've done all this learning. Well, let's talk about showing it. Step 1, get a small, friendly audience. Could be one person. Show them the basics, right? You're sick of FizzBuzz already. You've already done that. You could show them on your own laptop, work, CyberDojo, whatever. And this is all part of that old saying, if you want to learn something, try teaching it to someone else. Hopefully you're comfortable if this is a larger audience. I don't know what your comfort levels are. Maybe if it's more than 5 or 7 people, you might feel a little uncomfortable. If these are 2 or 3 coworkers, this may not be that big of a deal. And when you go through, just plan to deliver a basic demo and expose them to it. You could recreate your tech stack if you want. You could hand them a preloaded project, but show it off, whatever you do. That's Act 3. Act 4, advocacy. Good news, bad news, this is politics. This is a question of finding the right environment. Remember I talked about the iceberg? Maybe there's a small project you might be willing to talk people into. Ask yourself already, is your team really good at doing test last development? Are you comfortable with code that you're working on being easy to change? If not, well, you might want to consider how you do want to approach things. Think about how refactoring is viewed. To me, good environments say refactoring is like cleaning dishes. You got to do it. You make a mess, you clean up after yourself, you clean as you go. And ask yourself, how much is the greenfield versus legacy? I've heard different definitions of legacy code. My current favorite definition of legacy code is code developers are afraid to change. That may even have tests. That could even have a high level of unit test coverage, but that may still mean that there's certain complex concepts or tooling that's not as supportive as people would like to be able to go in with confidence and easily make changes. Step 2 for that advocacy, find supporters, other crafters. I'm sure that's why a lot of you are here. Those that are open to this idea of see it, do it, show it, breaking things down in small steps. You could try saying, hey, there's this code retreat thing coming up. It comes up every year in November. And when you do things and you start talking about this and you get into the politics, I like to tell people to keep an eye out for how people respond. This is a little bit of the soft skills coming in. You will find folks who might fall into each of these categories here as the advocate. Someone who's like, yes, let's do this. The follower. Okay, I'm not sure, but I'll go along. The uncommitted. The guy on the corner who's checking his watch. He only showed up for the free pizza while you did your fizz buzz at lunchtime. The detractor, who's speaking up and throwing stones. And then the last one, which is possibly the most dangerous, is the saboteur, who's going to go to your manager with all of the biased articles printed out about how TDD destroys things. I don't know, a good thing to address the saboteur. If you find something, let me know. Last but not least, Act 5. This I revised. It was originally piloted, and I started thinking about it after people's input. And now I'm down to pilot it or fake it. And it's 5 steps or 4 steps either way. If you're going to do it and do it in your organization, you've got to get the buy-in. You got to find a project, get the buy-in. You're managing people's expectations about how things are going to go and what you can work on. And assuming you're successful and you've got good traction and you're shipping good code and developers are happy about it, show it to the boss. Move it up the chain of command or whatever, and let people know, hey, we're doing better tactics, better approaches to building software, and this is what we're getting out of it. If you can't do that, you can always fake the project. The cool thing there is you can explore everything you want. You could do a rough clone of whatever it is you might be fighting with at work that's giving you problems, and you want to pick at it in ways that you couldn't possibly do at work on a branch that would be maintained even. Gives you the opportunity to try pairing CI/CD, trunk-based development. And if things don't work out, you can start shopping that around to show your new boss. And so in the end, the total of my message here, no one can stop you from learning and growing but you. Since AI is all the rage at the moment, I put this into a deepai.org generator. And I said, an angry programmer charging at you with a sword and a laptop. Not quite sure how the picture came out. The sword looks like it's kind of embedded into the table. And I don't know where his hands are, but you get a little bit of the concept. And that's basically it. That's my approach and my angle on software engineering. I believe that life is too short to work with garbage code. I've done it before. I don't want to do it again. And that's my thoughts on where I'd go, how I'd do TDD. My bio, as mentioned in the meetup, and for a little bit of a free plug. Unfortunately, there was a 25% staff reduction when I was at Industrial Logic last year, and I was one of them. And so I'm available now, contract, full-time, remote, Seattle hybrid. And I'm joking, don't try and engage me for children's parties. I think children deserve better than that. So there we go.
Nice. That was great, Garrick.
Thank you.
We had some questions where some of us were answering them in the chat. But there's one, do you recommend that Scrum Masters get hands-on experience with TDD? As John asked that.
You know, my approach to that is I would suggest if you can find the opportunity, if someone is doing mobbing, invite yourself into the mob or make yourself part of the mob. If you're not familiar, if you haven't heard the term mob programming or ensemble programming, it's like pair programming on steroids, where you've got multiple people taking turns. Someone's the driver, someone is a navigator, and then the rest of the mob is kind of helping direct the work. Do a little Googling on it. That may be the safest way to getting some familiar with TDD, is if you've got a high functioning team that's doing this sort of stuff anyways. If you want to learn for your own, just your own understanding, I wouldn't say no. I mean, not at all. Even just learning the basics without necessarily getting in and doing a lot of like, mocking framework or doing stunts. Just going through and understanding like FizzBuzz and how, one step at a time you're evolving the design gives you an appreciation for what's being done, as opposed to what, if you're a Scrum Master, if you haven't come from a technical background, if you haven't been a programmer before, I'm sure in some cases it may seem like magic if you've ever stood behind or watched some developers work on something and they just write code and they just write code and then maybe they manually test it. I don't know. And sometimes we have to, maybe if we're troubleshooting stuff. But again, I don't think it would hurt. I definitely don't think it would hurt.
Yeah, I actually I had a product owner on our team and she was just interested in like pairing, and
Yeah.
so she had an hour free, so we just sat down, started pairing and TDDing
Uh-huh.
all of her stories, and it's just like curiosity. If you don't force it on anybody, but if the Scrum Master wants to learn, go ahead and show
Abs
them.
Absolutely. And the other thing I will
Absolutely.
call out is being really happy to see that is that one of the whole things about Kent Beck's original approach to extreme programming and the concepts around the Agile Software Manifesto and everything, and all the Agile with a small a, was trying to heal the divide between business and technology. And from a pessimistic standpoint, you could make the argument that to a large extent, it's failed. And I would say that part of the reason why it failed is there have been attitudes that have prevented the adoption from the business side. Because the conversation has really been a matter of bring us technologists in, we can use our understanding to help business and possibly give you insights, give us a seat at the table, help us help the business. And that ask, I think, in and of itself, while it was totally honest and totally wholehearted and an effort to improve things, may really have been seen as someone wants a piece of my pie. And so, from my standpoint, anyone who's willing to talk and learn and understand and be brought into the conversation of technologists saying, hey, we're excited about what the business is doing. We want to help you, help us learn more. Anyone who's receptive to that, latch onto them, help them out, promote them in the organization. Tell other developers and other higher ups, man, so and so, best PM I've ever worked with. I've been building software for 15 years. If they leave, I might follow them. Stuff like that is literally, I mean, that's literally like, kind of the small politics and stuff that will make a difference in terms of how organizations, respond to change and deal with the fact that building software is a moving target and continues to be. So, is there another question?
I think Michael wanted to share his answer on that one too.
Oh,
Did you?
sure. Go
Well, I said
ahead.
I'd chime in on that on with the Scrum Masters being part of TDD. I mean, I've known English teachers and vice presidents who have sat in circles like this, and cross training is good. Um, these silos that we have, whether it's I'm the people person and you're the techie person. I mean, I hate this Scrum Master as an anointed title. And when I was a Scrum Master, I was a team member. I didn't want to be the Scrum Master. I happen to do some things better than other people. They happen to do some things better than me, and we called ourselves team members. So call it cross training. The
Mm-hmm.
Army is really well known for this. If you're 6 months on this job, go somewhere else. Um, like 500 years ago, the Japanese broke into the auto industry with these terms. I think it's called walking the gemba. Like it's literally getting down on the factory floor. So if you're an engineer or a VP, you're supposed to get down and walk on the factory floor and see what really happens. There's a lot to be said for doing that. Whether it's your VP sitting down at the coding session or the marketing person, or I love what you said, Garrick, because it's kind of the same thing. Like everybody can learn something from somebody. And let's
Right.
not silo ourselves as the smart technologists
Yeah.
who are angry at the pointy hair boss and pissed
Right.
off at the people who do the money. Like,
Yeah.
we're all in this together.
Yeah.
Share, learn,
Yep.
and you go sit in on their meetings. I'll invite you. You invite me. Let's cross train.
Yeah.
Yeah, for sure.
So
John,
it's
other than
if I can field one, Nick had asked Agile and TDD compatible. Um, I would say that technically they are TDD is an agile approach to building software. So very much so in that regard. And there's different things. I mean, if you see sometimes agile you see with a big A, and a lot of times people are talking about that, like, specifically like what people might call the agile industrial complex, like is it Scrum or is it this or is it that? And if there's anything that's touching software and you're trying to do it in an adaptive approach, then yes. In fact, TDD is incredibly helpful in that regard, because the test is the first client of the code, and that test also serves as documentation. Comments can lie. One of my favorite developers like to say that a comment is either a lie or an apology. Um, an apology that I couldn't make the code clear enough, so here's this big block explaining what's going on. Or by the time it changes, it's become a lie because someone changed the code and what the comment says isn't what it does anymore. And you may laugh and say, oh, that couldn't possibly happen. But if you write code long enough, you will see that. You will see it and you say, oh my gosh, Garrick was right. Um, so
Yeah,
yeah.
I think one of the most important things about agile is to be agile is to get feedback. And one of the most important things in test-driven development is getting that feedback. And so like those two things, like just they go well together.
Right. So there's another question about how do you deal with these objections? TDD won't work for real projects. Um, that's in a lot of cases for those, or it takes too much time, or creates too many test cases, makes it difficult to maintain. So one at a time, real quick. Won't work for real projects. I usually have to ask, what is the scope of real? Because in some cases, depending on the organization, you will get into organizations that are what I call IT users, or what could be working as what you would call, if you ever watch Star Trek, and Star Trek The Next Generation, and if you watch Lower Decks, because that's like kind of the fun new cartoon version, there's a race called the Packlids. And the Packlids are not too bright, but they love technology. And they will grab onto technology and they will cobble it together to solve their problems without understanding what it does. And I have seen organizations that I would honestly say are close to Packlid organizations where their approach to maintaining software and using it and evolving it and making it work to fit their problems is a discussion they don't want to have. And so what they're looking to do is talk to vendor A, to vendor B, and to vendor C, and to cobble together something that's going to give them a solution. And in cases like this, those are situations where you will find, if that is the real project, that you're going to have trouble because you don't have some things that are designed to work together, or in some cases be testable. You may end up with real issues if you have an organization that works that way. I would personally suggest, if you're operating in an organization that works that way, you might want to see what you can do to spread your wings and fly somewhere else, because they're not a software development organization. They're an IT shop that's hobbling along and waiting for the next thing that's going to blow up on them. And I'm sure there's stories that people have told, oh, this project, it was terrible and that was terrible. They'll also may very infrequently have discussions about successful projects. And so in that case, TDD may not work because they're not really building software. They're cobbling it together. And there you can run into a lot of issues. As far as a couple of the other ones, let's see, was it takes too much time? The funny thing about this is that to me, TDD only takes too much time when you're first starting out and you've got so much that you can just hold it in your head anyways. By the time the system starts to evolve, that you realize that you're not so sharp that you can't hold the entire system in your head and every single little detail, and neither can anyone else on your team, you're going to wish you'd done TDD. Believe me, because that additional bonus layer, because to me, it's honestly just a bonus layer of safety net coverage that makes sure you don't break something or miss a requirement on your next iteration. TDD is the only thing that gets you there. I haven't found anything else that does. And again, if you start with a small system, you might be able to get away with it. If you can keep a system small as a utility, even then you could get away with it, or just do a little bit of test last. But if something's going to grow and requirements are going to grow, you'll paint yourself into a corner without test coverage. And then
I really like G. Paul Hill's lump of coding fallacy
yes.
in the chat. Like you forget like once you start doing TDD how much I used to debug,
Mm-hmm.
like that.
Absolutely. And then to me, I don't necessarily TDD can create some excessive tests, but that's where the refactoring comes in. If you recognize like, well, hang on a minute, we've got an integration test that really kind of covers this, so we don't necessarily need A, B, and C. I've done those deletes a bunch of times. People that have gone through, especially when you're pairing and mobbing and you've got other pairs of eyes to take a look at that and help give you the decision of, yeah, let's kill those tests. They're not adding as much value to the system. But that goes back to some of the things that feed into the other kind of core practices along with TDD of pairing, of continuous refactoring, of continuous integration. Recognizing that, if you've got some test redundancy, okay, you've got some test redundancy, get rid of the redundancy.
Yeah, thank you very much for addressing those. Yeah, and definitely, I think I think one thing, and you probably covered it earlier, but like the the initial moment inertia is very high, right? In a lot of
Yes.
organizations, especially if it's a group of developers or who work together the same way for years and years, and you're like this new hotshot guy who comes in and tries to push TDD, then yeah, I think that's one thing. The other thing is also like if you are a consultant and you build code this way and but then you're giving it back to the organization to maintain and they get scared, right? They're like, oh my God, what's like I have hundreds of test cases and I changed this one thing and now 25 of them are failing. And so
Right.
that's kind of where I was what I was trying to address there. So but
Yeah.
thank you.
Yeah.
I really appreciate it.
No, that's a good point. And it's actually kind of funny when you mentioned that if you change one thing and dozens of tests break, that's a little bit of a test anti-pattern, or it's an indication that you've got a lot of complexity with regard to how your tests are structured. So,
Right. But I think if I may add one more, sorry, Michael. One thing, I read Kent Buck's book over the holidays, and he actually is actually quite pragmatic in that section 3 that you mentioned.
yeah,
One of the things I took away from it is like he actually is very ruthless about deleting test cases.
yeah, oh yeah,
When the design
Good.
changes, he deletes a lot. He actually changes the test cases. So I think that's something that when you're first learning or when you look at some of the videos and stuff, you don't get. So
hmm
that what makes, I think, yeah, I think you have to be also know that you can also delete your test cases. You can also change
exactly,
them. They are
yeah.
not static.
Yeah.
So
Well,
thank you.
and also as a side note, that's the great thing about source control is that
Right.
if you go through and you say, oh, what was that? Let me go and search. Michael, did you have something? No,
I
you may
think
have
it's
frozen. Oh, yeah, may have to let it go. Cool.
um We had a question earlier about what was the difference between a fake and a mock. You might have answered that one.
Right, right. The way that I like to sum it up, mocks will use and traditionally speaking, a mock, they're both test doubles. They're both standing in for real code. And depending on the tooling involved, a mock could rely on like an interface being defined, like in a statically typed language, like you need to have an interface anyways. Or with some modern tooling, you can mock real classes. And so it's just kind of a little bit of syntactic sugar that you don't see what you're doing it. But mocking will have its own tooling and assertions and expectations and way to set up an artificial test double to make it look like it's interacting with your code a certain way. For a fake, the funny thing about a fake is that it's actually literally just that. So if you could imagine that you've got a you've got a repository class that's a user repository, and then you've got a fake user repository, and the real user repository talks to a database. The fake one could have like three fake users, Larry, Moe, and Curly, because I love the Three Stooges. And those are the only three users in the fake repository class. And so you literally code it up so it's got the same interface, like find user by name, authenticate with a login with a username and password or whatever. And so the interface is exactly the same. In fact, if you've done it well, you've like pulled out that as an interface. And then fake implements that interface. Everything there is faked. None of it talks to a real database. And you ask yourself, it's like, okay, well, why would I want to do that? It's like, well, at that point, you can have a fake and then set it up with a little bit of extra tooling to do whatever it wants, that you don't have to learn all of the mocking toolkit to say, oh, how do I make it throw an exception? Oh, do I make it throw an exception only when this person logs in? Do I do X, Y, or Z? The fake actually lets you do something as complicated as you want with behavior without having to remember, oh, okay, well, this is JMock library, and I have to set the mock up this way, and I have to do it that way, and I have to do this before I call that. And to me, this will sound dumb, but it can be more cognitive overhead to learn the mocking library than to just go ahead and write a fake that'll fake out what you want to do in the first place. And a lot of times that fake will have examples of things that are in the problem domain, things that you care about, like, what if I couldn't talk to the database? How does that look? Is that an error that's reported back to the user? Is that a log call that has to be made that then fires off an alarm? Better have tests for that. We've got monitoring, don't we? That can be easier to bake into a fake than it is to actually try and wire up and put into something into a mocking frame. So go out. There's some good blog posts out there. I think they're like use mocks, not or use fakes, not mocks. That'll give you some good arguments.
I mean, what do you think about like mocks as a code smell? Like Arlo Belshi would talk about things like that. Like what about like mocks is a problem in general? Like your design is not right if you're using mocks.
See, and that's why I'm taking the soft argument of preferring fakes to mocks. And he's taking the hard line, fakest argument of don't even mess with them. They're not worth it. And so I'm giving you the soft sell of why I think fakes are better.
Yeah.
And I love Arlo. He's a great guy. I really respect a lot of stuff he's done. I agree with him. I also think that telling someone flat out isn't as convincing in some cases as letting them fight a little. And so what I would like to
Nice.
suggest is take a look at a test and say, how many lines of code do I have to write to contort my mocking framework to do what I want versus how easily could I write a fake that just does it? And look at those in comparison and look at them with some of your more complicated classes and ask yourself, it's like, what's going to be better to maintain in the long run? So
Yeah, that's where I'm at right now. Like I've always been on teams that use mocking frameworks, and I'm there now where in my personal projects I've been using test doubles now, and I'm liking the expressiveness of the test
Yep.
that just don't have when then return, but it's actually like talking the domain. So that's
Mhm.
nice. And
Well,
I've also
the other
heard,
thing that comes along more stringently if you're using more strongly typed languages like C# or like Java or something like that is that you're going to go off and you're going to want to declare that interface as an interface. And then all of a sudden, the mock is the client of the interface and your class is the client of the interface. And you really start thinking more, what am I publicly making available? What's the contract here that I care about? Which again makes you think more as opposed to, oh, I can just mock all this sort of stuff and the mocking framework will let me get away with murder. So,
yeah, and I've also heard that like with Mockito and like other mocking frameworks that because of the reflection and the test time increases like and once that scales up to like thousands of tests like it actually increases the amount of time that it takes for the test to run.
right. Yeah.
Yeah.
Sure.
I haven't tested that out personally, but yeah.
Yeah.
Michael, you had your hand raised earlier.
Well, it seems like I came back to Garrett saying a similar thing again. But my point was, what are testing? And to steal Garrick's thunder, it's testing your understanding of the problem. I mean, we say it's testing the code, but it's really testing your understanding. And so, are there too many tests? Okay, well, I can't hold it all in my head. I need more tests because I don't understand it. Or that what you're talking, Garrick, about like, well, what about this? What about this? Like, you're basically saying, I don't understand this problem. Let me learn about it.
Mhm.
Oh, by the way, you were talking about code, but mostly you were talking about you and your team's understanding. And
Right.
that's what the T and TDD is about.
Yeah.
Oh, by the way, it happens to be code, but
That's
it's
true.
really about human understanding,
That's
testing my
very
human
true.
understanding.
Yeah. Cool.
Any other questions?
I had one. I missed the intro. Is the red shirt important?
No, it just
Tell,
I
tell
felt
us
like
about your
wearing
away team.
the away team red shirt. So I was going to wear something a little nicer than a t-shirt. That's all.
Eric dressed up as a failing test.
That's right. Just to see if anyone would notice.
Manny, Mo, and Jack, or is it Curly and no? Yeah,
All
it's a
right.
great presentation. Thanks, Gary.
Yeah, thank you. No problem. Thanks for having me.
There's
It's fun.
there's a lot of wisdom in those slides. Decades.
Thank you. Yeah,
Ago.
there's a few good there were a few favorite points that I wanted to get in there, but trying to figure out good ways to condense down. So and again, stuff if you're not familiar with them, some of those books, especially if you'd never heard of London School versus Detroit School, some fun articles about that, and it'll make you think about what you're doing if you're already going in and doing TDD. What of those styles you might realize whether or not you thought about it, you're biased towards. So
There's another question that if you could share the slides.
sure. Is there a good way to do that in terms of like get that to you or
Yeah, we have a Discord you can join, or you can send it to me and I'll throw it in Discord, or I'll
okay.
just throw it in the meetup. Maybe that'll be better.
Okay.
Uh, We'll do it somehow. You